Hello, my name is Maisie Anderson, and this is my lab report for Physics 2212 Charge Tape. So what was the purpose of this lab? The purpose was to observe the interactions between charged pieces of tape and determine the amount of magnitude of the electric force on the tape. Our experimental model was using 2 pieces of clear tape, a ruler, a flat surface, and heavy objects for support. I used 2 board games, and our computational model was made on GlowScript. As a preview of the results, I found that the electric force on each piece of tape was 1.962 times 10 to the negative 3 newtons, and the electric charge on each piece of tape was 3.27 times 10 to the negative 8th coulombs. Fundamental principles for this lab. Firstly, we have Newton's second law, which is that any change in momentum is proportional to the net force applied. So F net equals final momentum minus initial momentum divided by change in time. Coulomb's law describes the force of attraction or repulsion between 2 electric charges, which are either positive or negative. So the force, or the electric force, will be equal to the electric constant times charge 1 times charge 2 divided by r squared times r hat. And then the gravitational force is the attractive force between 2 objects with any mass, which would be the force of gravity equals negative g times m1 times m2 divided by r squared times r hat. However, for smaller objects on Earth, that would just be F equals mg. So initial conditions for this lab, the length of the tape that I used was 0.2 meters. The tape mass thus was then 2 times 10 to the negative 4 kilograms. The tape width was 0.02 meters, and the tape area was 0.004 meters squared. The area of an atom, for reference later on, is 1 times 10 to the negative 20 meters squared, and the number of atoms in a piece of tape is then 4 times 10 to the 17th atoms. For my experimental model, as I talked about briefly before, I had a system where I had a piece of tape attached between my 2 board games and a loose piece of tape that I held in my hand. The attached tape was my system, and my surroundings was the loose tape and everything else. And as I moved the loose tape closer to the attached tape started to float away. And the minimum distance between the tapes when they were floating away was 0.07 meters in my experiment. So the gravitational force on the piece of tape was 0.00196 newtons, and the electric force thus has to be equal in magnitude for there to have been equilibrium right before the tape starts to float. So then the electric force also must be 0.0196 newtons, and from that I was able to find the electric charge, which was 3.27 times 10 to the negative 8th coulombs. And then the number of electrons lost, I was able to calculate from the electric charge divided by the charge of one singular electron, which I then found to be 2.04 times 10 to the 11th electrons. And the ratio of electrons to atoms on the sticky surface, I found to be 5.1 times 10 to the negative 7 electrons per atom. For my computational model, I've shown my code here, but I essentially demonstrate, as you can see on the right, how I treated the 2 pieces of tape as point charges, and I have the force of gravity going down from the top piece of tape, and it's equal in magnitude to the electric force pointing up, repelling it from the second piece of tape below. And I have the values that I found on the computational side listed as well on the right. So what assumptions did I make? I ignored air resistance. I treated the long tape as a point charge with the charge concentrated at the center of the tape. I assumed each piece of tape had the same amount of charge evenly distributed along the length of the tape. Possible errors I could have made in this lab would be potentially having an unequal distribution of charge on the tape, and as I held the tape and moved it closer to the other piece of tape, I may have lost some of the charge. I also could have potentially made errors in measuring the distance between the tape or the sizes of the tape. So for further discussion, what if the electrons had positive charge and protons had negative charge? What would change about the observations I made? The observations would be the same. Like charges still repel and opposite charges will still attract, so that wouldn't change. And why is it important to handle the charged tapes as little as possible? The charges will neutralize when the tape comes into contact with anything else, as the tape would try to regain lost electrons, so the charges would change. So in conclusion, this is just a recap of the electric force I found for each piece of tape and the electric charge I found for each piece of tape. And here's just a photo of my charged piece of tape attracting a charged pen. Thanks for watching.